All right, these are more examples of the trapezoidal rule. So we already did one before. It's the same stuff. I just want to give you more practice with it. So you can see here that we have our function right here. And again, to get that, we take our calculator, plug it in for the y, and then we go to our window and we plug in our interval. So we're going from 0 to 4. And then now we're pros at it. Let's find out what our delta x should be too. So we're going to go from 4 to 0 with 4 subintervals. So that's 1. Our subinterval is 1. So just so we have this nice picture, it'd be nice if it did the trapezoids too, huh? But our scalar here is 1. So now if we go zoom fit, it should give us our picture, obviously shrunk or stretched in this case, but it's the same graph. There you go. See, just like that. You can see there's the little lines. It's already cut, so we know exactly where to place them. Everything looks perfect. So we end up with this trapezoid, right? And so what we need to do now is use the trapezoidal rule. Well, we end up with these trapezoids, the trapezoidal rule for each of these. So we're going to take our delta x over 2. And so that's going to give us 1 over 2, right? And then we're going to take that and multiply it to everything. So 1/2 bracket, and then our first number is 0. And then remember, we're going to get 2. So this 1 is used to make the area of that trapezoid, and that f of 1 is used to make the area of that trapezoid. So we have 2 of them, plus 2 f of 2s, plus 2 f of 3s, plus an f of 4. And there you go. So now all we have to do is plug that in our calculator. It spits out the answer, and everything is good. So let me shrink it real quick. Okay, so second quit. Get out of there. All right, now we're going to plug it all in. Make sure we have a half. So 1/2 parenthesis, and then we're going to do f of 0. So again, remember, whatever the y equals is, that's what we're going to be using for our y1. So vars, scroll over, enter, parentheses, and then 0. We hit plus, and now we have 2 of these. Enter, parenthesis, and the next one is 1, plus 2, enter, and then parentheses 3. All right, oops, 2. So you gotta double check everything. Remember, we have 5 in here, 5 terms, because we have a subinterval of 4, so we're gonna get 1 extra. Each of these requires 2. Plus, and then the next one, which is our 3. And then the last one. Parenthesis 4. All right, close the parenthesis, hit enter, and we get 0.876, we'll say 2. 0.8762. And then I've already got the Desmos link here for this calculator. Remember, these are modifiable. This is just a basic link of this one. It's already set up, but you can plug any function you want in, any interval, any subinterval, and it'll spit out the answer and give you a picture. So if you click on that link, there we go. And you can even see, again, if we change the subintervals, the number of them, you can see that we are getting closer, right? Right now it's a little bit under, right? Our error here is actually a positive. See? But as we get more and more, those trapezoids start to actually fill it in much nicer than they would before, and you're getting something that's closer. But we're only dealing with 4 subintervals. And so there we go. So we know that the integral from 0 to 4 of x squared over 1 plus x squared dx is approximately, and we know that this is under because you can do a math 9 on this and figure out exactly what it is, or you can use the Desmos graph. All right, let's do another one, because these are fun. So we're going to go from 1 to 3. We're going to do 8 subintervals. So 3 take away 1 divided by 8. It's 2 over 8, 0.25 again. So we're going to go from 1 to 3. And again, we should really plug this in our calculator to show where I got the graph. So we plug in the function, we go to our window, and we go from from 1 to 3. And then our width is 0.25, right? Because we now have that in there. And we hit, not second, that's going to give us a table, which is fine, but we just want the graph. And it doesn't show up, right? Because what we were supposed to hit? Zoom 0 to fit it. There we go. So you don't want to hit graph. And obviously we have some space here, so I always like to go back to the window. Okay, yeah, my y min. Because remember, this is the area from the curve to the x-axis, so it's to where y min is 0. So we want this as our picture. That is the area that we want under the curve. All right, and then now we can draw our trapezoids. And obviously we don't have to if we're just approximating this. We can say, oh, well, this is 0.25 over 2. And then we're going from 1 to 3 when we're going to add 0.25. So this is 0, so 1. And then 1.25, 1.5, 1.75. And if you're like, oh, I'm just not that great at adding decimals, well, you can even go into your calculator and go to your table set. We're going to start it at 1. Our change is 0.25. You go to your table, and it lists them all for you. So we're going to go from 1 to 3. Those are the 9 numbers that we're going to use. So then we go f of 2, f of 2.25, f of 2.5, f of 2.75. So you got to show work. So no matter what, you need to have these numbers in there. I'm going to shrink it up and move it. Okay, but we should still draw a picture of our trapezoids. So this is going to get cut into 8 parts. So again, it's from 1 to 3. It's even, so it's nice. So we draw our line, and then we cut those in half, and then we cut those each in half, and that will give us 8 parts because we're drawing 7 lines. See, it looks nice that way. And so we don't have to put 1.25 or anything on there, but remember, we're connecting the dots to draw the trapezoid. So you're just connecting each line endpoint to each endpoint all the way across, and it draws all of our trapezoids. So that is the area that we're approximating right there. So now if we plug this in our calculator, it'll tell us our answer. And so we plug in the calculator just like before, 0.25 over 2, and then we do 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 1. And we get 3.5349. And then we check our calculator, our Desmos, and it's the same thing. And you can see this one's actually an overestimate. We're above. But there's our nice picture of everything we have. All right, and then I just noticed this. I mean, put it in the calculator because we know to put 2 of each, but I forgot to put 2 on each of these. So we really need to, I even said 2, 2, 2, 2, 2, 2, and didn't even notice it. But remember, everything in the middle gets 2 because it's used twice, each one. So for this trapezoid, we use this line. And then for this trapezoid, we use that height, and so on and so on. So that's base 1 for this one, and it's base 2 for this one. It's base 1 for this one, it's base 2 for this one. Base 1, base 2, base 1, base 2, and so on. All the way through all of it. So make sure you have the 2's on there as well, even though our answer matches perfectly. All right, and there you go.